Hello, this is Mrs. Serkis, and I'm here to talk to you about orders based on the patient's body weight. There are a lot of times that we are going to need to take the patient's weight into consideration. And here's an example. An order reads 5 milligrams per kilogram per day. This means that we need to give the patient a total of 5 milligrams for each kilogram of the patient's body weight per day. So, if a patient weighs 12 kilograms and the doctor orders 5 milligrams per kilogram per day, how much medication will the patient receive each day? So what we'll do is we'll write it as 5 milligrams, we'll put that in the top, and we'll put the kilograms and the day at the bottom. And then when we multiply by the kilograms, this is very often the first step we're going to do. And we're just going to put that over 1, so that cancels out the kilograms. And when we do the multiplication, we end up with 60. And the last unit standing are milligrams per day. Now, what if, same situation, the doctor orders 5 milligrams per kilogram per day, but they say to divide it in 3 equal doses, then how much will the patient receive for each dose? Well, if we've got 60 milligrams per day, and there are 3 doses in a day, we can use that as a conversion factor, make it 1 day over 3 doses. Why did I put it 1 day over 3 doses? So that the days would cancel and we'd end up with units of milligrams per dose. So that gives us an answer of 60 divided by 3 is 20 milligrams per dose. Okay, so let's move on to another level of difficulty. Our patient is a 3-year-old who weighs 34 pounds. The order is for this thing that I can't pronounce because I'm a math teacher, of 5 micrograms per kilogram subcutaneously 1 hour before they get the anesthesia. And on hand, we've got the same drug in a concentration of 0.5 milligrams per milliliter. This is a lot of information. We know that because there's kilograms here and pounds here, let's go ahead and pick that low-hanging fruit and start by converting 34 pounds to an equivalent number of kilograms. And there are 2.2 pounds in a kilogram, so we'll put the 2.2 pounds here and the 1 kilogram there, and that cancels out the pounds. And for some places, they are going to want you to not round at all. For us, we are going to round this intermediate step to the nearest tenth. Now, before we do the rounding, it's 15.4545 repeating. And since we're going to round these kilograms to the nearest tenth of a kilograms, we're going to look at the digit to the right of the tenths place. It's a 5, so we're going to round up to 15.5 kilograms. So that's our first step, is converting the patient's weight to kilograms and round to the nearest tenth. The next thing we're going to do is to do some dimensional analysis to figure out how much to give the patient. Now, our biggest clue here is that on hand is 0.5 milligrams per milliliter. These milliliters tell us that this is a liquid medication and we're going to want to give it in milliliters. So let's start with that we know. So let's make sure the milliliters on top, and we'll make that 1 milliliter over 0.5 milligrams. And now we will multiply that by the milligrams. What do we have in milligrams? We don't have anything in milligrams. We have micrograms. So we need to convert between milligrams and micrograms. You can do it in an intermediate step, going from milligrams to grams to micrograms, or we're going to do this so frequently, we're going to end up memorizing that there are 1,000 micrograms in 1 milligram. How did I know to put the milligrams on the top? So they cancel. And now we've got the micrograms. Now we can use the order, which is in micrograms per kilogram. We want to get rid of these micrograms. So now we'll multiply by 5 micrograms per kilogram in the bottom here. And we'll put a 1 there just to remind ourselves that it's 5 micrograms for every 1 kilogram of the patient's body weight. So now that cancels the micrograms, and the units we've got are milliliters per kilogram. Now we're going to go ahead and multiply by the patient's weight, 15.5 kilograms. And that's not a ratio, that's just a weight, so it's just over 1. and that cancels our kilograms, and now the units have driven us towards what we need to do. So we're going to multiply the numbers in the top. 5 times 15.5 is 77.5. And in the bottom, 0.5 times 1,000 is 500, and our units are milliliters. So now 77.5 divided by 500 is 0.155 milliliters. But if we look at the type of syringe we're using, we're going to use the smallest syringe possible to make it comfortable for the patient and to get as precise as we can. So we're going to use the smallest of the syringes, and that means how the bigger markings are in tenths, so the smaller ones are in hundredths. So we're going to round that to the nearest hundredth so that we can use this small syringe. Rounding that to the nearest hundred, there's 2 decimal places, the digit after the hundredths place. In the thousands place, that's a 5, so we're going to round that to 0.16 milliliters. You might also see that because it's a child that you should round it down to 0.15 milliliters. Either one of those answers would be acceptable for a test, but you need to follow whatever the instructions are for the place in which you work. Our next problem, we have a dosage rate of 60 milligrams per kilogram per day. We got a patient who weighs 200 pounds. How many milligrams should we give the patient every day? So we need to start by saying, okay, it's in pounds. We need to convert it to kilograms. If it's already in kilograms, obviously you don't have to do this step. And pounds here, kilograms here. 1 kilogram is 2.2 pounds. So 200 divided by 2.2 is 90.90 repeating. So rounding that to the nearest tenth is going to be 90.9 kilograms. And we're saying how many milligrams should the patient get. So we're going to see where the milligrams are. There it is. That's going to drive it. So we're going to use this to make sure the milligrams are on top. So it's 60 milligrams per kilogram per day. Multiply that by the kilograms. Just over 1, because it's not kilograms per anything. This is just the patient's weight. That cancels out the kilograms, and that gives us 60 times 90.9 is 5454, and that's in milligrams per day. We need to confirm that that answers the question. Milligrams per day. There we go. Okay, so now number 3 is related to this one. How much should the patient receive per dose if the drug is divided and given every 6 hours? So here you need to figure out every 6 hours is how many doses per day. I would not recommend trying to do this as a dimensional analysis thing. So I would just remember, okay, 24 hours in a day divided by 6 hours is going to be 4 doses per day. Okay, so that's 4 doses per day. So we're going to use this and find out how many milligrams per dose. So we're going to start right with what we got there, 54 milligrams per day. And for some of you, you're going to be able to just take that and instantly say, I know all I need to do is divide it by 4. If you recognize that, there's not a darn thing wrong with that. If you don't see it, then go ahead and change this into a dimensional analysis. 1 day, so it cancels with the days, 1 day over 4 doses. And that way the days cancel, and you see that it is 54 divided by 4 is 1363.5 milligrams per dose. Now, some of you might be wondering, well, how am I supposed to round that? What's the rule for rounding milligrams? And the rule is that there is no rule. And that's because you are never, ever, ever going to walk into a patient's room and give them a medication, and the last thing you do before you give it to the patient is to get out your scale and weigh the number of milligrams you're giving the patient. You're going to be counting pills of some kind, or you're going to be measuring a liquid, or you're going to be measuring, the inches of ointment. Whatever it is, it's not going to be weighing it. So this is always going to be an intermediate step, so just leave it unrounded, show the repeating decimal using 3 dots or the bar. That is not something we are going to have a rule about how to round that. Okay, next problem we've got is a prescriber ordered Epigen, 100 units per kilogram subcutaneously 3 times a week. The label reads 10,000 units per milliliter. The patient weighs 202 pounds. Let's start with that low-hanging fruit. Let's go ahead and convert 202 pounds into the number of kilograms that is. So kilograms on the top so that the pounds cancel. There's 1 kilogram and 2.2 pounds. So we're going to make it 202 divided by 2.2, that's a lot of twos, is 91.81 repeating. Whoops, I can't spell 81, right? Okay. And we're going to round it to the nearest tenth, so that's 91.8 kilograms. Now, the amount to administer. Well, the fact that it comes in a liquid, that the label reads 10,000 units per milliliter, we know that the milliliters is what's important. So 10,000 units per milliliter. We might use this, or we might use milliliters per 10,000 units. Which one's going to make sense for us? Well, this one is, because we want the milliliters to be in the top, so because that's going to give us the answer to the questions, how many milliliters. So it's 1 milliliter over 10,000 units. And now we're going to multiply by, well, we know we want to get rid of the units. What's our information about units? 100 units per kilogram. So that cancels out the units. And now we're ready to multiply by the patient's weight in kilograms. And that's just a regular number, so the kilograms cancel. And now we see our math that we need to do is 91.8 times 100 in the top, and then divide by 10,000. So that's going to be 9180 divided by 10,000. And that's going to be in milliliters. So that's going to be 0.918 milliliters. But as you can see in the picture of the syringe, which is the same syringes as what I've got here, we're always going to give the patient the smallest possible syringe so that we can get it as precise as possible, and to give the patient the smallest needle possible. They both end up with the same decision, and that is to use the smaller syringe that's less than a milliliter. And you can see, it's harder to see in my picture here, but you can see that it's calibrated to the nearest hundredth. See, this is 0.9, so we're going to go even smaller. It's not just 0.9, 0.95, 1. There's little markings in between here. Each one of these is 100th. So we're going to round this to the nearest hundredth. So we're going to give the patient 0.92 milliliters. And the way we're going to mark on the syringe to show that it's 0.92 milliliters is, here's 0.9. 0.92 is 2 tiny little markings to the right. I know it's hard to see on my picture here, but there's 0.92 milliliters. My last example is the recommended dosage for a drug is 20 milligrams per kilogram per day. For a child who weighs 45 pounds, what would be the appropriate amount to administer if the strength of the drug is 125 milligrams per 2 milliliters, and the medication will be given every 8 hours. So there's a lot of information here, and the every 8 hours is different from the milligrams per kilogram per day. So we need to go a little bit deeper here. So let's go ahead and figure this out. The strength of the drug is in milligrams per milliliter. What are we given? Okay, so we're looking for the amount to administer. So the first thing to figure out is, what are the units of our answer going to be? Well, it's an order in milliliters, so we're going to start with 2 milliliters over 125 milligrams. Oh, we should probably start by changing the 45 pounds. Let's do that first. Let's pick that low-hanging fruit. 45 pounds over 1 times 1 kilogram over 2.2 pounds. So 45 divided by 2.2 comes out to 20.45 repeating. So that's going to be 20.5 kilograms. Okay. So so we've got 125 milligrams. Okay, so we've got the milligrams per kilogram per day. So that's 20 milligrams. See, I put that on top so that it'll cancel out these milligrams. And that's per kilogram per day, right? So that'll cancel out our milligrams. We know when we want to get rid of the kilograms, so we'll start by, the next thing we'll do is multiply by the 20.5 kilograms over 1. So that gets rid of it. So now we're up to milliliters per day, but it's every 8 hours. And the amount to administer always, always, always means for a single dose.